So now we will move into discuss about the waveform of an action potential. So what are the major cell-generated potentials when we will applying the excitation into the human being physical body? In that first one is a that first one is a resting potential, and second one is a action potential, and third one is a depolarization, fourth one is repolarization, fifth one is a after potential. So that is different names of the waveform of an action potential. Now we will move into the waveform. Now we will move into the waveform and action potential. From in this waveform and action potential, x-axis is a time period. Now in this milliseconds, in x-axis is a time period in milliseconds, and y-axis is a voltage in millivolts. Y-axis in a voltage in a millivolts. From in this initial stimulus, any RBC, for example, I am considered as a RBC. I am applying some external excitation, means some force, physical force I am applying F in this direction. Now this is your cell. If what is the position of each and every Na plus and Cl minus and Kl plus ions we will observe from this action potential waveform. So now you are applying some force, so that initial force F1. Now in this case stimulus, so that is your initial stimulus. If cell is not move and go up, it will not go up direction. Your energy is not enough to move into certain potential. Now you are applying the F2 force, to some additional force is applying into your cell. Now second one is a F2 additional force is applying. Then second initialization, second this is your second, first initialization and second initialization. At that time also the cell is not taken a action. Then what you are applying, you are applying F3 force 3, more force is applying into this cell, more force is applying into this cell. Now this cell, it will be move from your resting state into your action state. It will be waveform, it will be seems like this. Now we will discuss about each and every. So name of the action waveform of the action potential. In this first one is a resting potential. So what do you mean by the resting potential? From this one, from in this one, what do you mean by the resting potential? Here the voltage of inside of this cell, which represent to outside of the semi-permeable cell membrane in resting state, this is a negative voltage, that is minus 62 minus 100 millivolts. This is your resting state. Now action potentials. Now second one is action potential. This is a voltage of inside of the cell which respect to outside of the semi-permeable membrane in a depolarized state. This is a positive voltage plus 20 volts. Action potential is a plus 20 millivolts. Now in this we will discuss depolarization. What do you mean by the depolarization? Now this is your depolarization, the process of changing from resting state to action potential. This is called as a depolarization, from this state to this state, resting state to action state. Next, repolarization, the process of changing from action potential to resting state. Repolarizations means the process of changing from your action potential to resting potential. This direction is called as a repolarization. Now last one is a after potential, that is called refractory period. After repolarization, after repolarization, the process of changes from action potential to resting potential is called as a after potentials. Now, this is the general waveform and different names of the waveforms in a human physiological cell membrane. A nerve and muscle cell may have 1 millisecond duration, whereas a heart muscle duration may be as high as 300 milliseconds.